Hello children, let us start the next session. In the last session, we were talking about the inertia. Inertia, it is the inherent property of every object with which it resists to change its state of rest or motion. Inertia is possessed by every object. In the every object, inertia exists. Because of this inertia, it resists to change its state. And there are different types of inertia. Inertia. Every object has inertia, and this inertia is measured by its mass. So we can say mass is the measure of inertia. Right? If greater is the mass, the inertia is more. If we take the example of two things, one is a car, second one is a truck. In the beginning, these two things are at rest. If we want to move them, if we want to move the car and a truck with the same speed, to move with the same speed, force is to be applied. And that force applied depends on the inertia possessed by these two objects. Here, obviously, more force is required to move the truck. It is because the truck has greater inertia. It has the greater inertia than the inertia of car. In the same way, if both are moving already, to stop them, to stop the car and the truck, again different forces required to stop them, because the inertia is greater in truck. So to stop or to move anything, the force, the magnitude of force required depends on the inertia of that objects. If more inertia, greater force is required. Okay. Then we move on to the types of inertia. वैसे there are various types of inertia. That inertia is based on their state. If anything is at rest, if it is at rest, we say it is inertia at rest. Inertia at rest. If it is in motion, a car is moving, a person is walking, then that objects are having inertia in motion. Inertia in motion. Then if a ball is rolling on a ground, on the playground, if a ball is rolling in a particular direction, that ball will roll continuously in the same straight line until some force is applied. That we call inertia in direction. Inertia in direction. These are the three types of inertia. And all these inertias, inertia at rest, inertia in motion, inertia in direction. There are so many examples for these. Inertia at rest. A duster is placed on the table. A bottle is placed on the table until the external unbalanced force is not applied. Suppose this is the surface. On this surface a block is placed, an object is placed. If an external unbalanced force, because as I already said, to change the state, the unbalanced force is required. Until the external unbalanced force is not applied on this object from any direction, it will not change its state, that we call inertia at rest. It will not change its state at any time. To change its state, external agent, external unbalanced force is to be applied. If already it is in motion, if the block is moving by some external source, it is moved. Suppose while you are playing, you kicked the ball. Once you kick the ball is rolling on the ground continuously. Unless the external unbalanced force is not applied on that ball, it remains in the same condition. It moves in the same direction with the same speed. Its speed will also not change. That we call inertia in motion and also inertia in direction. To change the direction also, the force is required. So, these are the three types of inertia. And then, if we define this inertia at rest means if an object is at rest, it will be at rest unless it is compelled by an external unbalanced force. Inertia in motion, if an object is in motion, it will be in uniform motion. Uniform motion means its speed will not change, speed remains same. If an object is in motion, it will be in uniform motion unless it is compelled by external unbalanced force. If an object is moving in a direction, it will move in the same direction unless it is compelled by an external unbalanced force. Separately, we can define these inertias. And this inertia is the property. It was discovered by a scientist, Galileo, who discovered the property of inertia possessed by every object. Inertia at rest, inertia in motion, inertia in direction. But beyond that, he didn't say anything about this term. That unless it is compelled by external unbalanced force, it will not change its state. Here, one thing is to be asked, how much external unbalance is to be applied? That is required. And that amount, the magnitude of unbalanced force required, is to be calculated. From which direction that unbalanced force is to be applied? That everything has to be calculated and found. That was not given by Galileo. For that, Newton comes. Sir Isaac Newton, who gave some laws for the force, to measure the force, that to get complete knowledge of force, Newton gave some laws. That's why we call that is Newton's laws of motion. It is Newton's laws of motion. So this Newton's laws of motion, it started from the inertia. ये जो inertia है, इस inertia के definition में से Newton continued the process that all the three types of inertia were combined. सबको combine करके एक law दिया था. He gave 3 laws. There are 3 Newton's laws of motion. First law, second law and third law. First law of